Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're diving into the producer-consumer pattern, a fundamental concept in concurrent programming. Victor, are you ready to explore this exciting topic?
Absolutely, Sheila. I'm looking forward to breaking down this important pattern for our listeners.
Great. Before we start, listeners, make sure you're familiar with basic concurrency concepts and Java's threading model. Now, let's kick things off with a quiz question. Can you think of a real-world scenario where the producer-consumer pattern might be applied?
That's an intriguing question, Sheila. It really makes you think about how this pattern might manifest in everyday situations. I'm curious to see what our listeners come up with. Without giving away the answer, I'd encourage them to think about scenarios where there's a flow of information or items between different processes or entities.
Excellent point, Victor. Now, let's start with the basics. Could you explain what the producer-consumer pattern is?
Certainly, Sheila. The producer-consumer pattern is a classic design pattern used to manage shared resources efficiently in concurrent programming. It involves two types of entities: producers, which generate data or tasks, and consumers, which process that data or execute those tasks. These entities interact through a shared buffer or queue.
That makes sense. So it's like a restaurant kitchen where chefs, producers prepare dishes, and waiters, consumers, deliver them to customers.
Exactly. That's a great analogy, Sheila. The kitchen counter would be our shared buffer in this case. Now, a key aspect of this pattern is managing synchronization between producers and consumers. We need to ensure that producers don't overflow the buffer and that consumers don't try to retrieve items from an empty buffer.
I see. So how do we typically implement this pattern in Java?
In Java, we often use something called a blocking queue. It's a special type of queue that handles the synchronization for us, making sure that adding and removing elements is done safely when multiple threads are involved.
That sounds helpful. Can you explain how we might use a blocking queue in a simple scenario?
Certainly. Imagine we have a producer that creates messages and a consumer that reads them. The producer would add messages to the queue, and if the queue is full, it would wait until there's space. Similarly, the consumer would take messages from the queue, and if it's empty, it would wait until a message is available. This way, they can work together smoothly without getting in each other's way.
That's really helpful, Victor. Now, what are some benefits of using the producer-consumer pattern?
Great question. The main benefits include 1. Decoupling, which means producers and consumers don't need to know about each other, just the shared buffer. 2. Scalability, so you can easily add more producers or consumers as needed. 3. Load balancing, where work can be distributed among multiple consumers. 4. And improved performance, as producers can work ahead of consumers, reducing wait times.
Those are significant advantages. Are there any challenges or pitfalls we should be aware of?
Absolutely. Some common challenges include 1. Deadlocks, where if not managed properly, producers and consumers can end up waiting for each other indefinitely. 2. Starvation, which happens when some consumers might not get enough work if the scheduling isn't fair. 3. And memory management issues, where if producers are faster than consumers, memory usage can grow uncontrollably. To avoid these issues, it's important to properly size your buffer, use appropriate timeout mechanisms, and consider using a bounded queue to prevent unbounded growth.
Those are crucial points to keep in mind. Now, let's increase the complexity a bit. What happens when we have multiple producers and consumers?
Excellent question. With multiple producers and consumers, we need to consider thread safety and fairness. Java's blocking queue implementations are designed to be thread-safe, so multiple threads can safely interact with them at the same time. However, you might need to use special techniques to ensure that no producer or consumer is left waiting too long for their turn to access the queue.
That's fascinating, Victor. Before we wrap up, let's reveal the answer to our quiz question. Can you share some real-world examples of the producer-consumer pattern?
Certainly. Some real-world examples include 1. Print spoolers, where print jobs are produced by applications and consumed by printers. 2. Video streaming services, where video chunks are produced by the server and consumed by the client. 3. Order processing systems, where orders are produced by the sales team and consumed by the fulfillment team. 4. And event-driven systems, where events are produced by various sources and consumed by event handlers.
Those are great examples, Victor. To summarize, we've learned that the producer-consumer pattern is a powerful design pattern that helps manage shared resources efficiently in concurrent systems. It uses a shared buffer to decouple producers and consumers, offers benefits like scalability and load balancing, but also comes with challenges like avoiding deadlocks and managing memory effectively. Java provides tools like the BlockingQueue to help implement this pattern.
Excellent summary, Sheila. It's a fundamental pattern that every Java developer should be familiar with when working on systems where multiple processes need to work together efficiently.
Absolutely. In our next episode, we'll be discussing another important concurrent design pattern, the read-write-lock pattern. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, happy coding.